Okay, guys, rational exponents, nice and quickly. So these are exponents that are fractions. So things like you see this here that says something like 8 to the 1/3, and 8 to the 1/3 means you might not know that you know this, but you do know this. That's the third root of 8, or the cubic root of 8. So whatever is on the bottom of the fraction here is the root that we want. So 8 to the 1/3 is the third root of 8, which means something. There's something times itself that gets me 8. And what is that something? Well, that's 2 times 2 times 2. Okay, on your calculator, you'll see something like this to help you find those answers. Okay, but I want you to be able to do these by without a calculator, by your brain, I guess. Okay, fifth root of 32 is the fifth root of 32. It's written like this. That means something times something times something times something times something gets you 32. And you work backwards and you get this. It's 2 times 2 times 2 times 2. So the fifth root of 32 is equal to, so this is equal to, that should have an equal sign. This is equal to 2. Okay, it gets a little more tricky, not really, but if you see 8 and 2/3, what you want here is the third root of 8. So the third root of 8, and then you're going to square it. So this says what root you want, and this says what you do with it after you get it. So I want the third root of 8. So from up here, I said the third root of 8 was 2, because 2 times 2 times 2 is 8. And then I square it, so 2 squared is just 4. So nice and simple. Here, again, the same question as above, just add to it. 32 to the 2/5. That's the fifth root of 32, which is 2, and then square that. If you get a negative involved, so that's 4 also. If you get a negative involved, so if you have a negative, so if I had something like this, 9, if I want the third, if I want that, okay, this is the square root of 9 cubed. Okay, so that number stays up top. This one goes here, so I want the square root of 9 cubed. Sorry, I said negative. We'll get to negatives in a second. So if that's the case, I want 3 cubed. So the square root of 9 is 3. 3 times 3 is 9. Times 3 is 27. If there was a negative here, all you do is right away you make this 1 over this, 1 over this, and 1 over this. The negative wins out. Okay, and that brings us to this stuff here, which is on the back of your note. 8x to the 2/3 times 64x all to the negative 1/3. So the negative right away says, okay, you know what? Bring this guy down here, 64x. Change that sign from negative to positive, and 8x to the 2/3 goes here. Now let me just go over this right here. Oh, sorry, that was this. That's what that was. So that's 8x all to the 2/3. So how do you deal with that with a variable of an x? You just throw this on top. We're fine with that for a second. We'll deal with it in a second. But right away, I want sorry, a little technical issue. I want to take this 2/3 and apply it to both the 8 and the x, and I want the 1/3 to apply to both the 64 and the x. So that's 8 to the 2/3, x to the 2/3, 64 to the 1/3, x to the 1/3. So I want the third root of 8 and square it. So the third root of 8 is 2, because 2 times 2 times 2 is 8. And then I square that to get 4. I'm left with x. I just leave this the way it is, x to the 2/3. Here I want the cubic root of 64. So what times itself gets you 64? And the answer is 4. And I still have this. Now I deal with the numbers and the variables separately. 4 divided by 4 is 1. And then I have a division question. X to the 2/3 over x to the 1/3. And let's figure out what happens here. That's x to the 2/3. Dividing it means subtract. So I'm left with that. 2/3 subtract 1/3. And I get 1x. 2/3 subtract 1/3 is 1/3. And there's my final answer. Here, if I have an adding or subtracting question, I just evaluate everything separately and then figure out how to add them like I would normally. So the fourth root of 16, so what times itself times itself times itself gets me 64, or 16, sorry, and that's 2. Here I want the same thing. I want the fourth root, that's 4 here. The fourth root is 16, but then I want to cube it. So here I want the fourth root of 16, but then I want to cube it. So the fourth root of 16 is 2, but 2 cubed is 8, so I'm going to have 8. Here I have the negative 1/2, so that means I want to subtract. This negative here is here, so subtract is subtract. I want negative 1/2, so I want the square root of 25, but because it's negative, it's on the bottom of a fraction here. So I'm going to get the reciprocal here. 25 becomes 1 over 25 because of this, and that turns into, that's a plus. So then that is 5. So let me just clean that up. That's 2 plus 8. The square root of 25 is 5. So now I have this 2 and 8 from before. So 25 to the negative 1/2 becomes 1. That becomes 1 over 25 to the half. 25 to the half is the square root. And oh, that's another thing, guys. This is the same as this. So if I write this, just root 25, that's the square root of 25. So the negative makes it a fraction. I still have the half, and now the half means I want the square root of 25. So square root of 25 is that. That is 10 subtract 1/5, which is 9 4/5, or I guess, what's that? Going to be 49 fifths. Okay, if you want to change this to 50, you could change this to 50 over 5, subtract 1/5, which would be 49 over 5. Either way. Okay, so hopefully that made sense. That's rational exponents. A little tricky, but just apply the rules that you know, and you'll be good. Good luck.